Welcome back, everyone. In the last class, I taught you guys Q and how to add an element to a Q, which is also in Q. I gave you guys this assignment. I expected everyone to have done this assignment. In the assignment, the tail pointer is defined as a what? As a pointer that points to the last element. But what I did was pointing to the next available space. So I expected everyone to have done the assignment. Okay, good. For this class, we will deal with DQ. DQ means popping out of a queue. If you can see, remember a queue means first in, first out, isn't it? The first item that comes in should go out first. If you remember in the last class, we were adding values to a queue, isn't it? And I said, before you add a value, what is the first thing you have to do? Check what? If it is empty, if it is full, isn't it? Check if it is full, because if it is full, you cannot add. If it is empty, you can add. If it is not empty but not full, you can still add, isn't it? So the most important thing is to check if it is full. If I have values 5, minus 1, 0, 3, 10, which is the head pointer? So this is index 0, 1, 2, 3, 4. So what index is the head pointer? The one I added first, isn't it? Which is index 0, which is element 5, right? And what would you be tail pointer? Index what? So according to my definition, tail pointer points to the next available space. So when you are adding elements to this queue, you kept increasing tail pointer, isn't it? So when you added the last element, then tail pointer should be equal to what? 5 to indicate that it is full, isn't it? Remember, our topic is a linear queue. Can you still remember? It's a linear queue. Okay, good. Now, tail pointer is 5, head pointer is what? Is 0. Is that understood? Now, let us pop out of this queue. Popping out of this queue means removing an element from the queue. Is that understood? Now, what is the first element we have to remove from this queue? The tail pointer? The element at the head pointer. Is that understood? Is that understood? Now, then let me take out this element 5 out. Is it out? So what should be the head pointer now? The head pointer should be what? Should be 1. Is that understood? So this should be the head pointer. So when the first element leaves, the next element becomes the first element, isn't it? Yeah. Good. Now, can you add a value, another new value to this queue? Is the answer a no or a yes? The answer is no. You cannot add another element to this queue. Why can't you add element to this queue? So you cannot enqueue in a linear queue because we only enqueue at the position of what? Of the tail pointer, isn't it? And at this point, the tail pointer is pointing at no element. Is that understood? Or no available space. No index of the array. So you cannot add. Is this understood, everyone? Good. Let us now pop minus 1. What should be the head pointer now? Is 2. The head pointer is 2, isn't it? Is no more 1. Why is it 2? It's pointing at 0. That is index 2, isn't it? So this is the head pointer. Can we still pop out again? Why? Because elements here exist. It's not yet empty. That means you must always check if it is empty before you what? Before you pop. Is that understood? Can we still pop out this guy? Yes. So what will be the head pointer? Is equal to 3. This is head pointer. That is index 3. Is that understood? Can I pop out this guy? Yes. What will be the head pointer? Index 4. Is that understood? Can I pop out this 10? Yes. What will be the head pointer? Head pointer is now equal to 5. At this point, it is what? It is empty. So what is the condition for empty? That will be what? When head pointer is equal to what? Tail pointer. Is this understood?
Yeah.
That means it's empty. But is this the only condition?
No.
If I have a new queue, a new one with no elements, that means head pointer should be equal to -1 and tail pointer should be equal to what? 0, according to my definition, isn't it? So is it empty or not? It's empty, isn't it? So what is this condition as well?
Head pointer. The head pointer is less.
It's not about the head pointer. It's about what? The tail pointer. That means tail pointer is equal to what? 0. Not the first element. There's no element. Yeah, it's equal to 0. Is that understood? So these are the two conditions for empty queue. When the queue is empty, it is either the head pointer is equal to tail pointer or the tail pointer is equal to 0. Is this understood? So when it's empty, what does that imply? You cannot pop out of that queue. That is the reason why you must always check if it is empty. Is that understood? Good.
You check if it is full to empty. You check if it's.
Yes, to add to a queue, you check if it is full. Because if it is full, you cannot add. To pop out, you check if it is empty. Because if it is empty, there is nothing to pop out. Is that understood? Good. Now, since that is understood, let's go back to this again. The head pointer is 0. The tail pointer is what? 5. Is this full? Good. Is this full? Can we add anything? No, we cannot. But can we pop out of it? So let's pop out this guy. When we pop out this 5, what does that imply? That means we increase the head pointer, isn't it? Do we increase the tail pointer? Remember when we are adding to the queue, what do we always increase? Tail pointer. Do we increase the head pointer? No. Now that with the queue, what do we increase? Do we increase the tail pointer? No. So that means the head pointer will now be equal to 1. Is that understood? So this is the head pointer. But there's going to be a problem. What is the problem? Can we add any other thing to this? No. But is there an empty space? That is the problem with a linear queue. Is that understood? That is the problem with a linear queue, which takes us to the concept of a circular queue. Circular queue. If it's a circular queue, yes, you can add an element to this after you have popped out. Is that understood? So that means after you pop out the first element, you increase the head pointer. Then you check the condition of the tail pointer. If the tail pointer is more than 4, then you make the tail pointer to be equal to what? 0. Is that understood? So after popping out the first element, then the tail pointer will now point to 0, which means we can still add another element. That is the difference between the linear queue and what? And the circular queue. Circular, when you get to the end, you start again. But linear, when you get to the end, you stop there. Is this understood, everyone? So this is now the tail pointer. So now you can add. Is that understood? Now, good. That implies that what if it was not full? What if I have this as, let's say, 5 initially? Let me go back to the initial condition. This is 5. This is the head pointer, isn't it? Now it was full here, isn't it? So let's assume it is not full. If it is not full, then this should be the tail pointer, isn't it? Can we pop out of this queue?
Yeah.
Yes, because it is not empty, isn't it? We can pop out. So which one do we pop out? The one at the position of what? Of head pointer. So that means I pop out this 5. After popping it out, what do I do? Increase head pointer, isn't it? So head pointer will now be equal to what? Will be equal to 1. So this is head pointer. Do we make tail pointer to be equal to 0? No, because there is still an available space. Is this understood? That is for a circular queue. There is still an available space. So we don't have to make tail pointer to be equal to 0. That was why I said after you pop, check the condition of the tail pointer. If the tail pointer is pointing at an empty space, you don't have to increment it. But if it is, you don't have to turn it to 0. But if the tail pointer is pointing at 5, probably there is a value at 4. Our tail pointer is now pointing at what? At 5. Is that understood? That means it was full. Then we set the tail pointer to be what? To be equal to 0. Is this understood, everyone? Good. So for a circular queue, the empty condition, will it still be tail pointer equals to 0? No. This condition is only for what? For a linear queue, not for a circular queue. Is that understood? For a circular queue, the empty condition is now the number of elements in the queue. That will determine the empty condition for a circular queue. Is that understood? If tail pointer is equal to 0 for a linear queue, it is empty. But for a circular queue, it does not necessarily mean it is empty. It may be empty or not, isn't it? For a circular queue. So for a circular queue, you use the number of items, not the length of array, but number of items. Because your array might be initialized with values. So if you use length of array, of course it will give you values. But the number of items may be 0. But the length of array may not be 0. Is that understood? So when you want to check if the queue is empty for a circular queue, you use number of items. So that means when you start adding items, you start to increment the number of items. You have a variable for number of items. So when you add the first element, you make number of items to be 1. When you add the second element, you make number of items to be 2. When you add the third, you continue to increase. When you now start dequeuing, you continue to what? To decrease number of items. Is that understood? When you start to dequeue, you continue to decrease number of items when you start to dequeue. So that after you have finished dequeuing, tail pointer will be equal to 0, isn't it? And number of items will also be equal to what? 0. With that, it is empty. Is that understood? When you are dequeuing and tail pointer is equal to 0, you will use number of items to check if it is what? Empty or not. That will help you to be able to identify if it is empty or not. So the condition for a circular queue is quite different from that of a what? A linear queue. Is this understood, everyone? Good. For a circular queue, you don't use head pointer and tail pointer to check the full and empty condition. Is that understood? But you use what? Number of elements. Is that understood? So let's write the code for linear queue to dequeue. When we are done, we will now write another code to enqueue and dequeue for a circular queue, since we understand both. Okay? So now, your classwork now is to write a code to dequeue. So let me give the question. So the question is, a function dequeue will check if the queue is empty and return a message if empty. If not empty, return the appropriate value and update the relevant pointer. Okay, now the question is, write the program code for dequeue. So that is the question. You have 2 minutes to do this, everyone. So this is the full question. Don't forget, it's a question on linear queue and not circular queue. Okay. Now everyone should be done by now. So now let me solve the problem. It says a function dequeue. Then I add it to here to this code, right? So def dequeue. A function dequeue. If you look at it, does it actually require its parameter? Why? We are just taking values and we're not adding values, isn't it? Okay, good. Check if the queue is empty. Remember, there are two conditions to check if it's empty, right? This is a linear queue, not a circular queue. So it is empty if what? Tail pointer is what? Equal to head pointer. Or if what? Tail pointer is equal to 0. Some of you forgot the second condition. And if you want to use a global variable, what do you have to do? You copy your global variable back to your function, isn't it? It's very important. This means it is empty, right? Then what do you return? Return Q is empty, isn't it? Now else, if it is not what? Empty, right? If it is not empty, what are you expected to do? To return the appropriate value and what? Update the relevant pointer. So what value are you going to return? The value at what index? At the index of, is it tail pointer or head pointer? Head pointer. When you want to add, you add to the index of tail pointer. When you want to return, you return at the index of what? Head pointer. So you return. What are you returning? Q array of what? Head pointer. Is that understood? Now, when you return this, what is the next thing? Update what? Relevant pointer. Any code you type after return will not work. Is that understood? Any code you type after return, because when the code hits a return, what does that imply? That is the end of the function. So that means you should update your pointer before returning. Is that understood?
Yes.
So it depends on you. You can decide to write variable is equal to this. Put that value to a variable. Then update the pointer. Head pointer is equal to head pointer plus 1, isn't it? And then what? Return the variable. It's fine. Do you understand that? So with this, you kept that value to a variable and do what? Update the pointer and return that value. With this, there's no problem. Or you can do it this way as well. You can write that head pointer is equal to head pointer plus 1. But have I returned? No, I have moved the head pointer to the next index. But I'm supposed to return the value at the previous index, isn't it? Then I will write return Q array of what? Head pointer minus 1, isn't it? Simple, it's still the same thing. Because any code you type after return will not work. Is this understood, everyone? Good. So what if you are asked to delete? If you look at this question, it does not ask us to delete that value, isn't it? If the question asks us to delete, if not empty, return the appropriate value, update the relevant pointer, and delete the value. What if you are asked to delete that value? This is what I'm going to do. It's very simple to delete the value. To delete the value, you follow the previous method I mentioned. Or instead of returning, you do what? You keep it to a variable. Is that understood? When you now save this to a variable, then you delete Q array of what? Of head pointer minus 1. You delete it. So that value will be deleted. Is that understood? Then you do what? Return var. It's as simple as this. So this does update the pointer, save the value at the previous pointer to a variable, delete the element at that pointer, and return the value you have saved. Is that understood? Good. So now going back to circular queue. For a circular queue, like I told you, we don't use the head pointer and tail pointer to track if the queue is full or empty. Is that understood? We don't use that. Why? Because if you have your queue Because of time, let me make it 3 elements. 3 minus 1, 5. This is the what? Head pointer. The tail pointer is at what? The tail pointer is at, this is 0, 1, 2. Tail pointer is 3. That means this is full, isn't it? Yes, it is full. So this condition is valid, that it is full. Is that understood? But if you now pop out this value, this becomes your head pointer. Is that understood? Is this still full? No. You have to make your tail pointer to be equal to what? 0. Tail pointer. But is it empty? No. But for linear queue, it is what? Empty. Is that understood? But for circular queue, it is not empty. So what do you use to track if it is empty or full? You use number of what? Of elements. What do you do? Use what? Number of elements. So let's start again. Now, this is a circular queue. This is a what? A circular queue. Index 0, 1, 2, 3. Having capacity of what? Of 4. Is that understood? Let's make head pointer to be equal to -1, tail pointer to be equal to 0. So this is the tail pointer, everyone. Is it full or empty? It's empty. But we cannot say it is empty. Isn't it? Because it can also, tail pointer can also be 0, even though it is not empty. Do you know? Good. In this case, that's why we need the number of elements. We will now set number of elements to be equal to what? 0 as well. So when you set head pointer to be equal to -1, when you set tail pointer to be equal to 0, you will also set number of elements to be equal to 0. So that is the pointer that you are going to use to track if it is empty or full. You only use head pointer and tail pointer to know where to insert an element and where the first element is. But you use number of elements to track if it is empty or full. Is that understood? Now, is this queue empty?
Yes.
Why is it empty? Is it because tail pointer is equal to 0? No. It is because what? Number of elements is equal to 0. Is this understood? Now, can we add a value?
Yes.
Is it full?
No.
If you want to add, what is the most important thing you have to check? Is it empty or full? If it is full, why is it not full? Is it because head pointer is -1? Is it because tail pointer is 0? It is because what? Number of elements is less than 4 rather. Because these are 4 elements, right? If it is equal to 4, it is full. If it is less than 4, it is not full. Is this understood, everyone? So the full condition is when number of elements is less than 4. Is this understood? What is the empty condition? Is what? Number of elements is what? Is equal to 0. That is the empty condition. Is this understood, everyone? Because when number of elements is 0, that means what? It is empty. You cannot pop. Okay, there's a mistake here. It should be what? Equal to 4 is full, yeah? Oh, good. Thank you for that correction. Equal to 4 is full. Equal to 0 is empty. So that means if number of elements is less than 4, you can add, isn't it? When it is equal to 0, you cannot remove, isn't it? Good. So now this is the question for a circular queue. An array is used to implement a circular queue with a space for 10 elements. So with this question, it's the same question as the previous one, but we have added what? Number of elements, isn't it? According to my explanation. So guys, solve this in 5 minutes.